today we've got quite a project that we've got to take care of. I've worked on this piece of equipment before, but this is going to be a little tougher than most. What we're going to be working on today is a damaged invisibility cloak. I was given this job through my highly classified channels, and they have asked me to not only solve the problem, basically what they've given me as a sample to work with of the invisibility cloak panel. And they've also given me the circuitry board, which we should just go ahead and pull this out and get started. They say we need to have been ordered by Pentagon Procedures to place it on top of some electrostatic bubble wrap, and we shall do that. So with this particular motherboard here, the speaker obviously is built into the equipment headset to provide any real-time service failure data in an audible fashion to the operator. Now, what we're going to be working on today is finding out where on this circuit board the issue is. I've got a screen here that's not lit up, which usually says system failure. Let me just unplug this. Okay, so we've got that unplugged, and we'll just put that right here. And we need to figure out what's going on. Let's get to the invisibility cloak. I've got a section here, and it is powered up. This is a 9-screen section. If you don't understand how invisibility cloaks work, it's quite phenomenal. This was pulled off of a tank cloaking device, which, if you've ever wondered, or if you've ever seen a car cover, which is sort of tailored and sewn to the dimensions of an automobile, you'll be able to clearly see that it fits rather nicely in these invisibility cloaks that the military does for tanks and other pieces of large ordnance equipment are just like that. They're like a car cover. It sleeves over the top of the tank, leaves room for the turb, visual and optical sights, etc., and skirts the ground just at the perimeter of or at the ground level, such that when the tank is moving, and these systems can operate for up to 6 to 8 hours on a charge, the tank is essentially invisible. And what happens is, imagine that this is this is a 9-piece. They have just 9 displays here. Only one is working. That's why we've got to go in and look at the circuit board and see why these remaining 8 are not functioning. So when the cloak is on, there are 2 points to the system, or 2 areas of the system that work in tandem. And you'll notice that what you're viewing here is actually the circuit board, because the camera or the viewfinder here is actually photographing what's on the outside. Now, the way it would work with a tank is that you would have this on one side, and on the other side you would have display cells such as this, and you'd also have a camera, much like a laptop. A camera would be on the in the corner there. You can't quite see it, but it is, the lens is there. And what that does is picks up the image on the other side of the tank and projects it to the opposite side. So when the tank is moving along, the opposite side of the tank is shooting footage, live footage from whatever it's moving along or stationed in front of, projecting it to the other side. And you've got about 16,500 cameras and view screens as we call them, on each tank, all operating synchronously and in perfect time. And it looks like basically a giant LED panel with many, many images from both sides of the tank, and also on the front and back side you're getting the same sort of instrumentation. So this is a fairly flexible material. You'll notice that it has some substantial weight to it. They've actually got protective film on top of the this cloaking device sample, and the film itself, the barrier, the fabric is a flat black material that reflects no light. It's a proprietary fabric. I think it probably costs anywhere from $60,000 to $75,000 a square yard. It's absolutely, it reflects no light, so it's completely opaque, and the transmitters and the viewing screens are mounted on this fabric. I do have it hardwired right now, such that it will feed to provide power to whichever system is up and running, and we have just one cell running. So now we need to figure out why one of the cells is working and why the other 8 are not in this sample. So when the current system is plugged into a tank, essentially what you have is this is controlling all of the apparatus, and we're looking at a very sophisticated piece of technology here. And what we have is a central processing area, and that would be these 3 processors. And we've got a continuous uplink to the actual tank command. In other words, there is an individual, one of 3 gentlemen in the tank, 3 soldiers in the tank, who are operating the tank. One of them is now dedicated not only to navigation systems and guidance, but he's also responsible for the invisibility cloak or the cloaking device. They use another term for it, but I cannot disclose that term at this time. They've not authorized me to do that. As a matter of fact, all this material, all the samples, all this stuff was sent to me in a very non-discrete, a very plain cardboard box. I received it, and nobody would have known what it is. So they sent it to my lab, and now we're here trying to fix it for them. So what we're going to do is first do a visible scan, and I'm going to use something that's rather curious. We've probably all seen them before, and that is what appears to be a light stick. However, this is not an ordinary light stick. This light stick, let's just get it operational here, actually allows me to pass over the motherboard, over the circuit board, and it will, using a reflective indicator that's been applied to this circuit board, if anything is shorted out, it will display as red just from a visual perspective. Let me take a look. I think I might have found something here. This is quite odd to have something in this area. This is the modulator here. What the modulator does for the cloaking device is it picks up it's essentially like a light meter. So if there is a different kind of lighting on one side of the tank versus the other side, it compensates for that. So as the tank is moving along, the modulator device will pick up any transitional on-the-fly changes in lighting and equalize all the screens. So essentially what you'd have is, with this piece of fabric here, obviously, we're assuming that all 9 of these would be operational. The lighting would look the same. You would have no reflections, no shadows, no backlighting, no shade. It would pick up the average lighting settings, if you will, for any environment, and equalize all of the little monitors on the cloak itself. By the way, handling the cloak, installing it, removing it can be done easily by one soldier. He can simply remove it, lay it on the ground, and manipulate it or handle it much like a parachute or even a tent. It can just be folded and then stored in a backpack or a lifting device or a bag of some kind. The interesting thing about it is the entire cloak weighs only about 45 pounds, so it's extremely manageable. All right, let me just do one thing here first. We can just let me just set the cloak aside here, but we need to get some. I need to get some power to this unit in here. So let's get some power into here. They use, believe it or not, Ethernet cable as their power links, power hookups. Primarily because the connections are stable. Everybody knows how to fix them with a simple tool. And let's power that thing up. Let me again check another area in addition to the modulator area. Let's check the link site, the link up feed. Right here. Pass. I don't see any short circuits there. Nothing glowing red. But I am concerned about some of the feed lines that go in here. I've got a couple I see that are red. And let me just get that jotted down here because this is very important. I best make a little image here just real quick of that modulator assembly area. So I've got two feeds here. They're coming in at about 10% red. So that's going to mean that we need to do a 90% reduction in feed. That's 24 ohms over DC voltage. These old systems are all DC voltage, so we get that's 204. That's just easier. It's 10, so that's no problem. So we've got about a 10. We need to do a 10 resistor uplink change. So what I'm going to recommend is that whoever is going to actually work on the motherboards, and they'll reprint these motherboards and just simply reinstall them in the equipment, the tanks, in their modular pull-out drawer system that they have. They just pull them out, put another one in, and you're set to go. No patch, no interior wiring work. It's just very simple. So what we're going to do is we're going to recommend that they connect two of these. I don't know if you can see them, but there are two, and they probably can't be visible to the viewer here, but these first two are glowing a little hot red, showing that they are shorted. And that's position number. Let's get the positions down because it's very important that we get the position yesterday. So I'm trying to get this. So position number 2 and 3. I would say 2 and 3 have to be. We better measure that to make sure though, because I think if you're off, they may mistake it for position 3 and 4. So that should be roughly about 1.2, 1.2. I'd say 1. I'd say we can only get down to using a hand ruler, obviously, a degree of accuracy would be probably about 2, position 2 and 3, 2, 3, 0.2 to 0.3 millimeters. I'll write that down here. Let's just take a look at that. Yes, these cloaking devices have come a long way. They started making them in 35 RX7 62 model resistor. Just wanted to make sure. I knew that. I know that resistor was constantly a problem. Constantly. Okay, so this particular motherboard, we've identified what the problem is. That's pretty much certain. But I will tell you that everybody thinks that when you're watching a Harry Potter movie, you're seeing your first invisibility cloak, and nothing could be farther from the truth. It may be that J.K. Rowling actually knew something, perhaps, or had a connection that really kind of brought her up to speed on the technology. Nevertheless, cloaking devices and invisibility cloaks and that kind of technology have been used since the 70s. It's just that they're only now very sophisticated and field-worthy for use. You can run these things and drape them over vehicles. You can outfit a soldier with a complete uniform. The units or the display size is much smaller. They're 1 centimeter by 1 centimeter screens, which is that's quite a bit different, isn't it? I'm just curiously. So that's an inch. If we go to the metric side, imagine this is for a tank, obviously. So this is 3 centimeters roughly. I'd say 3 centimeters, but 5. But on a uniform for a bodysuit, their screens are 1 centimeter square. So quite a sophisticated apparatus. And typically on an average soldier, there's about 6,500, depending on the size, 6,500 monitors and 6,500 cameras, obviously pointing it on the opposite side. It works with soldiers pretty much the same way when you're wearing the uniform. are wearing the outfit, as we call it. It's just referred to as the outfit. And they are easy to get in. There's a zipper down the back, and you sort of step into it much like you would an astronaut's suit. It does have a thermal system in it where it controls body heat by running a cold fluid through silicone tubing that, again, pretty much like an astronaut suit. So let's just take one good look here. I just want to see if this is accurate. I don't know. This does not look like a switch. Let's see if this switch is turned on here. I can't trip it. It's very strange. I cannot trip this thing. I'll check the feeder board. I see. I may have to strip these wires here. Let's just do that. Let's just do that to be safe. Essentially, I think I'm just going to pull them out, disengage them from this system. And here is a fuel cell for the motherboard, by the way. I don't know if you can see that. This is a fuel cell for just the computer itself. Really, really small. It's a polonium chip. It's completely sealed, totally safe, and generally doesn't give us any problems. Okay, yeah, so this polonium chip fuels the entire device, and this modulator, this piece right here, with the polonium, where did the polonium chip go? The polonium disc. There it is. Just make sure we have the polonium disc and set it aside. Whoop, there we go. Right there. We're going to set that aside over here now. All right, so the polonium chip fuels this device, fuels the motherboard. It is separate and apart from the tank itself. So if for some reason there's a catastrophic failure with the tank, electrical systems, the artillery system, the cloak will remain powered. This is just a small section again, but the cloak itself will remain powered so that there is still stealth factor involved with the tank. And that polonium power source really is an amazing upgrade to the system. This system, which is made by Ghost Industries, is fully self-contained. And when you drape the tank with the cloak itself, you turn it on, it stays on. There is nothing. Even an EMP, electromagnetic pulse, would not bring the system down. And that's what we like to see. So, again, just to review, I think one of the considerations that we have here is this particular portal here. It's not linking up. It's not linking up properly, so I've got to go in here and actually visually inspect and see what these leads are doing. And I believe they are shorted out, but let's just illuminate the situation real quick here, very fast. Double check again, triple check if we have to, many, many times, make sure it's right. Resistor 1 and 2, and so again going to be 135 RX762, replace resistor on all units. Make sure we get that done. One thing I will tell you, that is, this obviously is an ordnance size screen, and the screens that would be used on a personal or individual soldier's uniform would be substantially smaller. It would not work if you had these large screens, because the screens themselves would be probably visible, and it wouldn't. You're not talking scaling it up properly. So you've got to scale it down for a smaller asset, which would be soldiers. So whereas this screen is, let's just do it in metrics. So it's going to be 4 by, let's say 4. I'd say almost 4 by 4. Let's just call it square. These are 4 by 4 centimeters, but for a soldier, you're looking at 1 by 1. So it would be a 1 by 1 centimeter screen, approximately 6,500 on the average uniform or average soldier-worn device. A tank has probably, as we discussed earlier, a little bit more because even though they're larger, you still got to cover a broad area. So now that we know that this is the problem, let's just review as to the situation and why we need to restrict these. Because if I don't have this plumbed in here correctly, we could have a major problem. Okay, I'm going to restrict them. I tried to do this earlier. Copper exposures. Plug them into the underside of the heater board here on the reverse modulator panel. So that's good. That's good. Check for any shorts. Again, one more time. Check them for any short circuits. Don't see any. Still got the two over here for the feeder line to the internal tank modulation system, which should be fine. Just take a look at this switch over here. We do have a little bit of a bypass switch problem on these things occasionally. And I've got to go in there and solder these. Be technical. Good. Should be good. I'm liking that. Okay. So essentially when you have this type of equipment, you need to be, the stability of the system is absolutely imperative. If you have a tank involved in a field situation, you got hostiles out there again. If any of these shut down, one or two you can get away with. Imagine the LED signs that you see along the highway, and you're looking at them, and those units have 60 to 150,000 LEDs installed on them. Typically, they have, if you're driving through Las Vegas and you're looking at the larger units, they may have as many as 500,000. But on a typical unit, if you get 2 or 3 of these that fail, you're not going to be able to really distinguish it easily. However, if 8 fail out of 9, you've got a major problem on your hands. If you've got a tank sitting out in the open and all the systems are shut down, it's running silent, there's no decibel count coming from that tank at all while it's being scoped by a hostile enemy, you will quickly discover that tank visually by merely looking out into the field, and you see a spot, a little spot in the distance. And it can be discerned using software. So there is software now that can detect these systems being down. And we want to make absolutely sure that the polonium chip is installed in the system and that those chips are replaced every 6 to 8 months. And that way the system will stay online, and it is an autonomous apparatus. This apparatus will stay lit, fired up, powered up, and you will have no issues with it whatsoever. Let me just see something right here along this edge. Take this edge right here. There's no particulate matter in there. Okay. So no particulate matter in there. Try a little more. The thing I'm going to do with this modulator device is check the polarity of these adapters. Good, good, good. That's what we want. Perfect. Okay, those are good. They're modulating quite well. Let's see if that tripped anything here with this particular sample. And by the way, this sample, there's no way we can doctor it or fix the other 9 viewers, the other 9 the viewers and cameras. It's not going to allow for that because this was set up to fail. So it's designed for me to plug into the unit and hunt down the problem. Fortunately, we were able to visually observe, or visually assess, I should say, being a little more grammatically correct there, that we have a problem with this area, 1 and 2 resistors, which we've got the replacement. Those are going to be, again, 2 135R X762s, which we know we've got to fix. And I'm also concerned about this loading device here. This, if you look at it, it has got a little spinner in it. I can't really move it, but that spinner is actually a gyroscopic device for this motherboard, this piece by itself. So this motherboard, which if it was fired up, that screen would say system down because I don't have it connected. You can see there's no connection. So it would read system down if it had power to it. I've got the polonium chip out, as you obviously know, because I showed it to you. So that would be an issue. But I think what we've got here today is a wonderful demonstration of how simple this piece of amazing defense machinery is. The fabric itself, the viewers, the cameras installed as we explained, and the system. And this is the system. It's nothing. It's small. It occupies about 12 square inches and can be tucked into a access panel, unplugged very quickly, replaced very quickly on the fly, just as you'd replace an aircraft part. You can have the tank sitting out ready to go. You turn on the motherboard, you fire the systems up, everything's green, and bleep, you got a problem with the system. It's deemed to be something like this, resistors, and you change it out. You simply pull the box out, put another box in, it plugs into the fabric itself, and you're good to go. I hope you enjoy this video about invisibility cloak repair and a little bit of an inside look at our military's most valuable piece of defense hardware, and that would be the Ghost Industries cloaking device or invisibility cloak. Thanks for watching. If you cared for the video, make it known down below. If you'd like to get more of my sophisticated and technical videos where we explore different systems, please subscribe. Thanks for watching. Have a great evening.